So welcome back. Now, I thought the next thing we could look at is at the cross-sectional skewness and kurtosis in our panel. And then another video to think about whether returns are Gaussian. And a Gaussian test, like the Jacques-Barra test, is a joint test on skewness and kurtosis. Therefore, let's just look at skewness and kurtosis first. Right? So it's kind of skewness and kurtosis realized, and it's cross-sectional. Okay, great. That is what we look at here. Boom. Okay. So, start small. Wait a minute. Do we have the necessary package? Okay. Here, yeah. I learned from my last video where I just said, I don't know, I said so much. Let's just say I just reload that package, so the video is more self-contained. Okay, so we take from SciPy, import the stats package that contains skewness and kurtosis functionalities. And now I want to visualize the cross-sectional skewness. So we have the matplotlib library as plt, that's from above. Plt.give me a histogram and just plot the stats.skew of my RD panel. Okay, so now what do you know before looking at the data? We know all else equal, we have the prior thinking that stock returns are negatively skewed because of these negative crashes, boom, boom, boom. Now if you look at cross-sectionally at the data for the last 20 years, you see that most firms have a skewness around 0. There are some -4 skew firms, also a +6, that might be the Volkswagen, although I don't know. Okay, so not all firms are negatively skewed. There's dispersion. And the European data, that's why I like it so much, it's really dispersed. We have these millennium losers, we have the star potential, and we have the mostly German industry about like the, how did we call them? I don't know, but kind of these firms who do well, but who don't have the star potential. And looking at the plot of the time series, what their stock prices. Now, the next thing I want to do is let's just get a better feeling of what the stock's skewness looks like. So we will have a figure, yeah, at skew versus ticker. That's kind of what we plot. Okay, so plt.figure, and I want a fixed size of, I don't know, let's have it wide, 4010 might be too big. plt.plot. So what shall you plot? Plot the tickers on the x-axis. Now the tickers are the column names of our RM data, pandas data frames. Therefore plot the column names, RD columns, against the skew. Otherwise, plot the skew against the ticker RD, and I want a plus, not in line. Okay, so that gives us the skew of the tickers, and I also want a red line. What's my red line here for skewness? It's 0, because the Gaussian has a 0 skewness, and I'm moving towards a Gaussianity test, so I want to see which firms have a non-zero skewness in their returns. So plt.plot, and again plot the same x-axis, but now plot the 0 times numpy.once, and what shall it be? It shall be once across all my tickers, so it's rd.shape1, comma 1, and make it a red line. Okay. And then plt.ylabel, that is the skew, and plt.xlabel, it's just a ticker. All right. plt.show we don't need in our notebook, but I still do it. Okay, all right. that looks so small. Let's try some magnifying. I don't know, it's still awesomely small. So what do we have? Just visual inspection here. We see that most firms are on the red or above the red line. I don't know. We would have to do some proper counting. So let's see. The 1/n portfolio is here, so it has negative skew, right? So the market is negatively skewed, but it's close to the red line. So if anything, the market seems to be with zero skew. That's our Volkswagen. That's what I meant. It has the 6. Yeah, I knew because Volkswagen had the short squeeze, so just a couple of days where they were the most valuable stock, and that was a positive stock price innovation basically. So that leads to this positive skew. All right. Now you also see now, before we move to any statistical analysis, that short squeeze was a coincidence event. I just call it like that. It happened in the data. Do you think it's going to happen again? Because if you use backward-looking data to make forward-looking forecasts, that's what you work with. And that's why I like this Volkswagen example, because I don't think it's going to repeat. So the question is, shall I maybe ignore that data point for estimating higher moments moving forward? I don't do as of now. I just observe the data for now, but I hope I highlighted the point that you have to think about the data and not just apply a package. That's my learning point, or what I want to bring across to my students, who I observed. Just give me the data, basically. Yeah, but no, think about the data. Okay. And then here you have a couple of firms. They are right at zero skewness. There's a little bit of negative skewness here. Siemens negatively skewed. Some other firms here. Fresenius has a strongly negative skew, but I remember at the Z-scores plots, they had a couple of negative 10 or more standard deviation events. That is negative skewness here. And all the rest, it kind of hovers around zero. So that itself, skewness, doesn't seem to be the problem when it comes to asking the question whether I can use a Gauss distribution for characterizing these returns. Now, what about kurtosis? Yeah, we make another fig for kurtosis. Now, Gaussian densities have a kurtosis of 3. So we care about excess kurtosis. So what we do, again, just do some smart copy pasting. I want to plot kurtosis instead of skewness, so it's kurtosis. My threshold is now 3. Kurtosis, kurtosis. Okay, great. And I want the ticker. Okay. Boom. I have to magnify that picture. Okay. Okay. So you see the market has a kurtosis of really 3. So that tells me already the market is using Gauss distribution for the 1/n portfolio. It's not too bad. Skewness is around 0. Oh, my tea is empty. I need a break. Kurtosis is close to 3, so that's fine. We have Volkswagen again. A kurtosis of roughly 300. And my friends, that's just a short squeeze. So again, research shows us, because we want to move on to options eventually, and for options, we can back out higher moments, yeah, like these Bakshi risk neutral moments, mathematical algorithm, so it's correct, on transforming prices of options into the priced in moments of the risk density. But then you want to compare that to the P density moments, to the empirical data moments. And just estimating moments is a tricky thing with empirical data. It's sensitive to measurement errors because you take fitting errors, realized returns minus the forecasted return to the power of 4 for kurtosis, right? So if you have an error there, it's to the power of 4. And the short squeeze of Volkswagen is not an error, but it's such an influential point that it just jacks up that kurtosis. And if you now say, okay, Volkswagen has a 300 kurtosis, and you want to work with that, it kind of gives you kind of hope that that is a stable relationship here, but it's not, right? That kurtosis is driven by a couple of observations with that short squeeze, where it's not clear someone, okay, all right. What about else here? Yes, these other firms, so we have excess kurtosis. There's not a single firm that has kurtosis below 3. Okay, but they are around 3 here. Bayer has positive kurtosis or excess kurtosis. Fresenius again, but it's also, I believe, it's these these standard deviation events, and then here. Okay, great. So what do? We showed skewness and kurtosis in the cross section. Okay. I think that's all for now.